10th week grading. So good afternoon, everyone. Hope all is well. Hope everybody's doing all right, especially everybody out there in Zoom. So we're just talking about 10th week grading. If you saw the email, I opened up everything to May 1st. If by some chance, and one of your classmates just let me know that 10th week grading has been pushed back to next week. If you feel like your grade could have changed by next class or by next week, let's say next Sunday, you can shoot me an email. I can look at it, and then change it. But yeah, I'm not going through everybody's stuff and trying to, because I already submitted them. And I'm pretty sure it's not going to be a high percentage of grades that's going to change between today and next week. But if there's somebody out there, I will give you the opportunity to make that change. And let's say if you got a D and you want it to look better than that come 10th week grading, feel free to shoot me that email after you've done whatever it is you had to do to get made up. Outside of that, our next major grading is going to be the last, which is the final. And that's May 1st. As of right now, we got till May 1st because I believe final exam week is that week after. Let me say this real quick. Is that week after. So I may be able to squeeze out some more days, but as of right now, we're looking at May 1st as our final grading date, or final submission date. What you got?
I know you had said earlier in the year that
Oh yeah, we're gonna just do it all online. Yeah. So for those who are on Zoom, we're gonna do our testing online, our proctoring. So basically, all you would do is just tune in through Zoom, enable your cameras, show your ID to the camera, and then I'll shoot you the password so you have access to the test. So that's how we do our testing. Everybody's supposed to have computer access because that's how they do in math lab anyway. And so you just have to make sure you have your computer accessible on that day during that, those 2-hour blocks. Yeah. Yes, sir. Yeah, you can make notes. I won't take that from you. Yeah, that's fine. And so with that being said, and we'll talk about it more when we get closer to it. The best way to do it is once I post your final exam review, you can make notes off of that and streamline your notes according to that, and you should be straight for the final exam. Yep. All right, anything else? Anybody else before we get rolling? Everybody good? Straight. So last class we closed out 11-4, so we're getting into 11-5 today. 11-5 is short as far as examples are concerned. But it's a combination of, you see the title says probability, which was 11-4, fundamental counting principle, which is 11-1, permutation was 11-2, and then combinations 11-3. So it's all 4 sections, in this one section. So they bring them all together. And so since 11-5 is a little shorter, we're going to do a little bit of 11-6 and then close out 11-6 next class. So we're going back to our comedians. Remember, we had 6 comedians, 5 of them were men. 1 of them was a lady, 1 of them was a woman. It says, if the lineup is chosen randomly, what is the probability that a man will go first and a man will go last? All right. So don't forget, whenever we're dealing with probability, we have to establish our sample space first. And so that's your total number of possible outcomes. And that's with no stipulations, not a man going first, man going last, none of that. Just generally how many total combinations can be created just by the 6 comedians. So remember how we talked about doing it that time, I think it was 11-2, where we had our 6 blocks, our 6 time slots, and we had 6 comedians. So in that first box, how many comedians do we have as options? 6. As that comedian goes, then when we go to the next slot, we don't want to repeat the comedian, so we put 5 in the next slot, then the next would be 4, then 3, then 2, then 1. So that's the number of options you have for each slot. And so after you establish that, you multiply each together, and that'll give us 720. So any questions on just the general, how many different ways can we choose our comedians to go in what, in general order? So there's going to be 720 different ways we can order our comedians. So now our event is where it gets where it gets a little tricky, or we have to pay attention to detail. We still have the same 6 boxes, but remember, the first box we want a man to go, and in the last box we want a man to go. And so, like I mentioned before, we have 5 men and 1 woman. And in those boxes, we put how many options we have. So in the first box, we have 5 men. And if one of those men go in that first box, for the last one, we have 4 men. All right. So now when we get into the middle, it doesn't matter who goes, but you cannot forget the fact that you had a woman. So you would go 4, 3, 2, 1. And that 4 starts off with 3 men and 1 woman. One of them will go, then 3, then 2, and then 1. And then we multiply those numbers together and we get 480. So before we finish off the problem, are we okay with how we got our numbers? Make sure we're okay. Our sample space, which is 6, 5, 4, 3, 2, 1. And then our event, we just had to be strategic in how we put our numbers. We had to pay attention to what they were asking of us and what our options are for each box. And then we multiply those numbers together as well. Once you have your number of your event and the number of your sample space, you place the event over the sample space and then reduce. So 480 over 720. 240 cancels, leaves you with 2/3. Any questions? All right. Scrolling up. Good. Let me know if I'm scrolling up too far. Everybody done with the blue? All right. Now this one's a little wordy, but believe it or not, I took out some of the words. So, but I had to leave in some key things. So we have a lottery and it's set up so that each player chooses 5 different numbers from 1 to 69 and 1 Powerball number from 1 to 26. A player wins the jackpot by matching all 5 numbers drawn in any order and matching the Powerball with $1, with one $2, I ran the sentences together, and matching the Powerball with one $2 lottery ticket. What is the probability of winning jackpot? All right. So once again, lottery is set up so that each player chooses 5 different numbers from 1 to 69 and 1 Powerball number from 1 to 26. A player wins the jackpot by matching all 5 numbers drawn in any order and matching the Powerball with one $2 lottery ticket. What is the probability of winning the jackpot? Okay. So once again, we're talking about probabilities. So the first thing we want to establish is the number of our sample space. And so we can do that by first calculating 69C5. So in other words, how many different ways can I choose 5 numbers out of 69? And then how many different ways can I choose 1 out of 26? So remember, in order to get this lottery ticket, we have to choose 5 numbers out of 69 and then choose 1 number out of 26 for the Powerball. All right. So 69C5 is going to be 11,238,513, and then 26C1, 1 out of 26 is just going to be 26. Multiply those two together. The fundamental counting principle tells us to multiply them together. 292,201,338. So that's the total number of different ways we can choose or create a lottery ticket. You know, we're choosing 5 out of 69 and 1 out of 26. Any questions? Everybody good? Now my event is the number of tickets. Notice it says with one $2 lottery ticket. Why is it not scrolling up? There we go. So my event is just one. And that one is not one number. It represents one of these combinations. One of these 292 combinations of choosing 5 and then 1 out of 26. 5 out of 69, 1 out of 26. And so our probability is going to be 1 in 292 million, you know, if you were to round it. Any questions? Any questions on that? So now I'm gonna do an extra question. I just want to show you how futile our attempts are at actually playing the lottery and how it actually works and how the money continually grows and grows and grows. It's really because you don't really have a shot at winning. And I'll show you why in a second. It's completely luck. But before I scroll up, is everybody done copying? Everybody good, everybody good. All right, so what if I want to increase my chances? Let me erase some of this. All right, if I want to increase my chances, first, if you would divide the 1 by 292,201,338, we get this number right here. And I have my eraser still on. There we go. We get this number right here. All right, we got 0.0, got 8 zeros in front of the 3. If I want to convert it to a percentage to better put a value on my chances, I move my decimal 2 places to the right, and that still puts me at 6 zeros in front of my 3. Now, this is how much a percentage of a chance that I have on winning if I just buy 1 ticket. Now, if I want to move this decimal over to increase my chances, then what I need to do is add zeros behind the 1 in order to increase the chance. So in order to get my decimal right here, I need to put 1 0. So that's 10 tickets. To get my decimal place right here, add another 0, that's 100 tickets. And so you can see where I'm going. This will do 1,000. This is 10,000. So this 10,000 tickets, and I'm not even close to having a 1% chance of winning. So here, 100,000. I got 1,000,000 tickets, and I'm still not at a 1% chance of winning. And so to get my decimal place right here, I need to buy 10,000 tickets to have a 3% chance of winning. And so if you think about it, even if these tickets were $1, that would be $10 million. But here, these are $2, that'd be $20 million that I would have to spend to get a 3% chance of winning. And so that's how the lottery is set up. And it's kind of jacked up, but people constantly throwing their money in there. So just showing you your chances if you ever want to get into it. But any questions before we look at this last problem out of this section? Everybody good, everybody straight. All right. So the last problem that they gave us, we have a club consists of 5 men and 7 women. 3 members are selected at random to attend a conference. Find the probability that the selected group consists of, we have 3 men, and then B, 1 man and 2 women. All right. Club consists of 5 men and 7 women. 3 members are selected at random to attend the conference. First, we want to see what's the probability that the group consists of 3 men. So the first thing we want to do, as always, if we're dealing with probability, is establish our sample space. So now the sample space is the total number of possible combinations. So we're looking at the fact that we have 5 men, 7 women, that's 12 altogether. What's the probability of choosing 3? What's the total amount of ways we could choose 3 out of 12? Because it's 5 and 7. And that would be 220. So that's our bottom number, our generic total number of possible combinations. You know, whether it's 1 man, 2 women, 2 women, or 2 men, 1 woman, all men. Those are all your combinations, 220. Now our event, we're talking about just choosing men. So that means 3 men, but those 3 men are not coming from the 7 women. They're only coming from the 5 men. So that's why it's 5C3 for our event number. All right. And then once you have your event, place it over your sample space. That's 10 over 220. And that'll reduce down to 1 over 22. All right, no problems, everybody good? All right, so last one like this, we have 1 man and 2 women. So our sample space is still the same. We haven't changed the problem, so that's still 220. But then the 1 man and 2 women is very similar to the problem that we did when we dealt with the Democrats and Republicans. We have the 1 man that's only going to come out of the 5 men, and then the 2 women that we're going to choose will come out of the 7 women that we have totally in the group. So 5C1 will give you 5, 7C2 is 21. Then we multiply those together, which would be 105. Then we place the 105 over the 220, and that will reduce to 21 over 44. $11,500. All right. Anybody still copying before we go to the next thing? We're good. All right, so that's it for 11.5. So we'll do a few problems in 11.6 and then stop where I stopped with my other class. A good place to stop and close out 11.6 next class. So we're looking at events involving not and or, and eventually we'll be looking at odds. Right. So the complement of your event, or complement of E, is the set of all outcomes in the sample space that are not in event E. Complement rules, they're really all the same rule, just written and manipulated differently. So we have the probability of event E plus the probability of not your event will always equal to 1. So it means if you have one, then you can find the other one. If I have the probability of my event and I want to find the probability of not my event, I can subtract it from 1. And then if I have the probability of not the event, I can subtract it from 1 to find the probability of the event in question. All right, scrolling up. So if you are dealt 1 card from standard 52 card deck, find the probability that you are not dealt a queen. Not dealt a queen. All right, so find a probability of not being dealt a queen. We're going to subtract the probability of being dealt a queen from 1. So we did that back in 11, that was 11-4, looking at the probability of being dealt a queen. Remember, there's 52 cards in the deck, and then there are 4 queens in the deck. Yes. Last purple right there. Yep, no problem. And so place that 4 over 52 and then reduce. So I'll pause right here. I want to make sure everybody's with us before I just keep going. No problem. All right. So we found our queen, the probability of getting a queen 4 over 52. That reduces down to 1 over 13. Now to find the probability of not getting a queen, we're going to do 1 minus 1 over 13. Because remember, that's that probability of getting a queen. Can I scroll up on the green? Very good. All right, so don't forget your fraction rules, if I can get it out. The 1 is going to turn into whatever that denominator is over itself. So it'll turn to 13 over 13. And then 13 minus 1 will be 12. So it's 12 over 13. You got 12 out of 13 chance of getting a queen, or of not getting a queen, excuse me. Questions. Scroll up, everybody good? How far can I go up? Good. Okay. So we have a circle graph that I have under here. This is the wording first. It says the circle graph shows the time breakdown in minutes for various aspects of the average 190 minutes of an average 190-minute NFL TV broadcast. What is the probability that a minute of the broadcast is not devoted to game action or actual football? Scroll up, got a copy in that. All right. So once again, we're looking at what is the probability that a minute of the broadcast is not devoted to game action or actual football. So we see that we have the breakdown of an actual game, 190 minutes. And we see we have replays, 15 minutes, commercials, 63 minutes, shots of players standing around, 67 minutes, shots of coach, crowd, cheerleaders, etc., 34 minutes. And then we have actual game action right here is only 11 minutes. All right. So when we look at the breakdown, game action is 11 over 190. So the probability of getting some game action is 11 minutes over the 190 minutes. But we want the probability of not getting game action. So that'll be 1 minus the 11 over 190. That 1 turns into 190 over 190 based on that denominator that we see. And then do our subtraction, 179 over 190. All right. Questions before we look at the next one. All right. Next one is another circle graph. The circle graph shows the distribution by age group of 214 million car drivers in the US, with all numbers rounded to the nearest million. If one driver is randomly selected from this population, find the probability that the person is less than 80 years old. All right, were you taking a picture of the word problem or the clip? Oh, you good? Or?
Yeah.
Okay. Cool. Gotcha. So here is the circle graph. Notice it has the ages of 19 and younger, 9 million, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, then 80 and older. All right. We want to know the probability the person is less than 80. So we'll take the 80 and older, which is 8 million. So the probability of less than 80 will be 1 minus the probability of 80 years and older. And so that's going to be 8 out of the 214. Remember, the 214 is all of these added together. So there's 8 over 214. That 1 is going to turn into 214 over 214. Then subtract. So it'd be 2 over 6 over 214. And then we can reduce by 2 to give us 103 over 107. All right. Questions, any questions? Very good, everybody straight. All right. So that's where we paused at from our last class. They ran a little longer because they had a little more questions and stuff. So this was a good place to stop. Next class, we will get into 11:6 and hopefully close it out and look to move on and get into our last chapter. Yep. Any questions? Yes.
Do you think this isn't like, do you think that we're gonna get to all of them?
Yeah, because I think chapter 12 is only like, I left my book in the car. I think chapter 12 is only like 4 sections, at the most 5. So we'll be finished, probably have some extra time too. Yeah, because certain sections in that one, like it's like mean, mode, and median is like 1. And some of y'all probably already seen that, taking the average. So chapter 12 is not that heavy. So yeah, most definitely we'll be able to knock it out. Yeah, no problem. All right, any other questions? Everybody good in Zoom? Everybody straight? All right. Well, if you guys are good, I'm good. I will see you next class, looking to close out chapter 11.